All right, guys. Hope you're having a great Thursday morning, Thursday afternoon, or Thursday evening, whenever you're listening to me. Today, we're going to talk about dividing polynomials by a monomial. This will be the last section before your first quiz. Your quiz is going to be on Monday, and that is going to cover multiplying binomials by binomials, monomials times polynomials, binomials times trinomials, and dividing polynomials by a monomial. So before we get into the new topics, we have to first recall the quotient rule. Okay, and the quotient rule says that if you are dividing x to the a over x to the b, then we can treat this as x to the a minus b. Okay, so we need to keep that in mind. So in order to jog your memory a little bit, I'm going to start with example 1 here. Example 1 is going to be 36x to the 5th divided by 4x to the 3rd. Again, we can kind of take a look at these as individual type problems all in one. So we have this 36 divided by 4. So if I want to take care of that first, 36 divided by 4 is going to give me 9. And then we'll take a look at this x to the 5th divided by x to the 3rd, and we're going to key back in here to our rule. We can treat that as x to the 5th minus 3, which is going to be x squared. Okay, if that didn't quite jog your memory, I'm going to go through another example here. Example 2, we have 18y to the 3rd divided by 6y to the 7th. And again, we're going to take a look here at the first piece being 18 divided by 6. 18 divided by 6 is going to give me 3. And then my second piece here, this is where things get a little bit tricky, but not really. We have y to the 3rd over y to the 7th. And when I subtract 3 minus 7, I'm going to get y to the negative 4. But that right there should send an alarm off in your head and kind of jog back your memory and say, well, we can't have a negative exponent here. So if we can't have a negative exponent and the exponent is negative in the numerator, okay, our negative exponent rule says that we can leave the 3 in the numerator, but we must send that y to the negative 4th down to the denominator and change that y to the negative 4th to a y to the positive 4th. Okay, I'll give everybody a second to copy that second example down. I'm going to erase example 1. Feel free to pause the video if you'd like to kind of copy down those example problems in your notes. And then I'll do one more. Okay, I'm going to erase it. I'm going to do one more. This one's going to be semi-challenging, a longer type problem for you guys before moving into the new stuff. So this will be example 3. And this should all still be a review for you guys. We have 20a squared, b to the 4th, c to the 6th, and that is all over 24a cubed, b to the 4th, c to the 3rd. Again, you should really be treating these as like individual problems, and I'll highlight each individual problem for you so you guys know what I'm talking about. I'll highlight them in different colors. That way you kind of see that they're really smaller problems within a larger problem. And I haven't used this one yet either. Okay, so in the blue there, we have 20 over 24, which we should be able to say, well, 4 goes into both of those, and 4 goes into 20. So that's going to be 5 times, and 4 goes into 24 6 times. So 20 over 24 really simplifies to 5/6. And then we're going to take a look at the a squared over a to the 3rd. That's going to be a to the negative 1. So I'm not going to write that in the numerator. I'm just going to drop the a to the 1 in the denominator, a to the 1st power. And then we got b to the 4th over b to the 4th. Well, what we should realize there with b to the 4th over b to the 4th, that's going to be b to the 0, which is just anything to the 0 powers 1. So I can kind of get rid of my b's there. They go away. They simplify out to equal 1. And lastly, we have c to the 6th over c to the 3rd, and that's going to leave me with a c to the 3rd in the numerator, and that is going to be my final answer. Again, you could pause the video here so that you can, take a little bit of notes before you move along. The next piece that I bring in will be the new lesson. Again, these 3 examples should have been a solid review for you guys to kind of jog your memory on dividing variables with exponents. So a new type of problem that you can expect to see, let's see, we'll call it example 1. This is example 1 of the new material, is 6x plus 9 over 3. Now, to divide a polynomial, that's our polynomial, by a monomial, we have to divide each term of the numerator by the term in the denominator. So what that's going to look like is, well, first we need to take and rewrite this, okay? What you're going to do is you're going to get 6x divided by 3, and then you're going to get plus 9 divided by 3. That was, again, by taking this term and dividing it by 3. Okay? And then we took this term in the numerator and divided it by 3. Well, 6x over 3 is going to realistically be, well, 6 divided by 3 is, we'll get 2x here, and 9 divided by 3 is 3. So our final answer is 2x plus 3. Okay. I'll erase that. We'll do another example for you guys so you see it in action again. Again, I will increase the difficulty with each problem. So if that first one didn't make sense, maybe you want to go back to the beginning, restart it, and try it again. But what we'll do here is we're going to increase the difficulty just a little bit with example 2, not too much. What we're going to have here is 40x squared minus 8x divided by 8. Again, we take that first term, 40x squared, divide it by the term in the denominator, and then we have minus 8x divided again by the term in the denominator. 40x squared divided by 8. Well, 40 divided by 8 is going to give me 5, and the x squared can just drop down because we have no x terms in the denominator here. And then we have minus 8x divided by 8. Well, 8 divided by 8 is just 1, so we can write x. Again, we do not have to write that 1. It is assumed that there's a 1 in front of the x. The first 2 examples that I chose to show you guys did not have a variable in the denominator, okay? Just because a variable comes into play in the next example doesn't make the problem or the approach any different. It just adds a degree of difficulty to the problem. So I'll go ahead and erase this. We go to our third example. This one's going to be slightly more challenging, and we'll end with the real challenge as the fourth example. Example 3 is 12x cubed plus 15x, and that is all divided by 3x squared. Again, the approach is the same. We're going to take the first term here, which is 12x cubed, and we're going to divide that by the denominator 3x squared. Then we're going to take our second term here, which is plus 15x, and we're going to divide that by, again, 3x squared. Approach these problems the same. 12x cubed, so up here, 12x cubed divided by 3x squared. Well, 12 divided by 3 is going to give me a 4. X cubed divided by x squared is going to just give me an x, so that's 4x. Okay. And then we're going to deal with 15x divided by 3x squared. Taking a look here, 15 divided by 3 is going to give me a positive 5, except I have an x here and an x squared here. That would give me x to the negative 1, or I'll just write my x in the denominator here. And that would be the final solution there. Again, here we added in some variables with exponents, but again, if you treat each problem as one smaller problem, and you can break it into the smaller pieces, you will be just fine moving through this stuff. I will show you it with a much longer problem. Again, work through it at your own pace. Maybe you want to pause the video before I solve it, so you can see whether or not you're solving it correctly. But I highly suggest that you try to at least attempt it before I do it for you. This is example 4, and this is going to be a long-ish problem. We are going to have 28 x to the 5th, y to the 4th, z to the 3rd, plus 8 x to the 4th, y to the 3rd, z squared. All of that is divided by 4x squared, y squared, z squared. And again, I'll write this out as 2 separate problems. Here we have this piece here, 28x to the 5th, y to the 4th, z to the 3rd, all that divided by this piece right here. So I'll just rewrite that. What we're going to get there is, I'll write it down here, 28 x to the 5th, y to the 4th, z to the 3rd, all over 4x squared, y squared, and z squared. And then what I'll do is I'll take this piece here, this plus 8x to the 4th, y to the 3rd, z squared, and that is also going to be divided by this piece right here. Okay, so plus 8x to the 4th, y to the 3rd, z squared over 4x squared, y squared, z squared. So we'll work through that first piece here on the left here, 28 divided by 4. Well, everybody should know 28 divided by 4. It's going to give me 7. X to the 5th divided by x squared. Well, that's x to the 3rd. Y to the 4th divided by y squared. Well, that's y squared. And z to the 3rd divided by z squared. Well, that's just z. And then we're going to have plus 8 divided by 4 here. Well, that's 2. X to the 4th divided by x squared. Well, that's x squared. Y to the 3rd divided by y squared. Well, that's just y. And z squared over z squared. Well, that's just 1. So we don't have to actually write anything for our z's because those simplify out to be 1. And we cannot combine these like terms here. Or we cannot combine these terms because they're not like terms. So this is going to end up being our final solution. Okay. Again, if you guys have any questions, drop a comment in the Google Classroom, send me an email, shoot me a Google Hangout. If you'd like to see more examples, just reach out to me. I can create a video with more examples for you guys. That way you guys understand what's going on a little bit better. Hope you guys enjoy the rest of your Thursday, and make sure that you're staying on top of all of your schoolwork. Thanks, guys.